Good afternoon. Today we will be discussing operators in quantum mechanics. Now, operators basically are mathematical instruction which, when introduced into a wave function, brings out the Austrian value, as the case may be. So now, it is like when we have a function defined as Hamiltonian. Now, when you introduce it into a wave function, it brings out an Austrian value and a wave function. So now this is known as the Austrian value. So simply, a wave function in quantum mechanics is just like a mathematical statement that which, when introduced into a wave function, brings out its Austrian what value. And an example of the Austrian value is energy, e.g. energy, wavelength, etc. So if that is the case, so now how can we show that when we introduce an operator to a wave function, it brings out an Austrian value? So we recall that an Hamiltonian is the same as the sum of the kinetic energy plus the potential energy, and we can rewrite this as 1/2 mv squared plus vx, which we can call our equation 1. So now if that is the case, now we recall that momentum is equal to mass times velocity. Therefore, this can be written as mv squared over 2m plus v squared. Now we can rewrite it in terms of momentum as p squared over 2m plus vx, which we can call equation 1, 2. For a wave function, for a wave particle behavior, the Hamiltonian can be written as, in respect to the wave number, squared 2m plus vx. So we will be left with the Hamiltonian k squared 2m plus vx. So now when we multiply this whole equation 3 by the wave function, we have the Hamiltonian, the wave function, h squared k squared, the wave function, over 2m plus vx, the wave function. So it means that we can see the Hamiltonian wave function and the wave function h squared k squared over 2m plus vx, where the energy is equal to h squared k squared over 2m plus vx. Therefore, the Hamiltonian is giving us the wave function, the energy. So it means when you introduce an Hamiltonian to a wave function, that the wave function will now give you an Austrian value, which is what? The energy. Thank you.